All right, so we are making our way through the rest of chapter 3 here. And we were talking about just the idea of chemical reactions and the different components with it, and we were starting to move towards how we can use the idea of moles and naming and all this kind of stuff to come together to describe a chemical reaction, right? And so one of the things that we have to learn first is how to make sure everything's balanced. And then what we're going to apply with that is the idea of stoichiometry, right? And so what we were talking about with that is when I asked you guys, how to make water, and you guys started to do the math there, right? We got to build up back towards that is what it is, okay? So we should get through that today, but this is going to be one of those tricky topics, okay? Now, it seems initially tricky, but it's because there's a lot of math involved. And as soon as I say the M word, what do you guys do?
Cry a little bit.
Yeah, right. Okay, we cry a little bit. We curse our fate, and we consider becoming history majors, right?
No, we don't.
Oh, crud, I'm being recorded. All right, sorry. No, I'm joking, right? But it's one of those things where, again, if you remember the first day of class, I gave you guys that math kind of survey there, right? And if you guys felt comfortable with doing that kind of math, that's about as difficult as it's going to get. What's going to be tricky is just making sure we understand how to apply the addition and the multiplication and that kind of stuff at the right place, okay? And that just comes with practice. Right? But anyway, before we launch into that, let's go ahead and get started with prayer then, and then we'll continue on. But Lord, we just thank you. Lord, we just thank you yet again for another day that we can come before you, Lord, and just spend the time here learning about you and the world that you created and the things that you put before us, Lord. And we just thank you that you give us creativity and imagination and intelligence and wisdom just to seek after you with those, Lord. And Lord, we just pray that we do put all those talents and gifts that we do have in the pursuit of you. And we know that that pursuit is always the pursuit for truth and what you want, Lord. So we just thank you for your word. We just thank you for being who you are. And we thank you, Lord, for just guiding us and bringing us into your kingdom, Lord. And we just pray all these things in your name. Amen. All right. So, where we had ended, we were going through and just doing a little bit of practice for the balancing, right? And the unfortunate or fortunate news, whichever way you guys want to think about it, is that there is no magic way of doing this, right? It really just becomes we have to do it and check ourselves and go back and make sure that we don't miss any of the atoms that are in there and don't accidentally write the wrong number and that kind of stuff, okay? And so where we end up there at the bottom, if you guys hopefully spent a little bit of time just trying to finish this one problem before you guys came in today, this is where I ended up with my balancing here, right? So a couple of things that we did end up saying is that, usually we try to start with an atom that is in a single position on both sides. I believe we started breaking this one down with the hydrogens on both sides since they're only existing in one of the molecules there, okay? If you guys find something useful online for you guys, some kind of tricks or tips on how to balance things, go for it, okay? There are some interesting other approaches to this, and I'll leave it up to you guys to find it out. For myself, it's just a simple matter of using a website to balance it. No, I'm just kidding. Right? It's just, I just go through and I start to break it down one at a time until I get to the end, right? Yeah, what's up?
Could you possibly lower that thing, a little bit?
Is this in your way?
Yes.
No, because that's kind of aimed at me. I'm sorry about that. You want to move? I know you're in your comfy spot there. I really do apologize. We've got a couple of students who are out, so we're going to have to start recording everything. But maybe I could find another place to kind of hang this in for the next class or something like that. So sorry, but we'll work on that. I promise. Okay. All right. So now we do want to address one other maybe kind of idea or thought, right? So when we're dealing with our polyatomic ions, right, which you guys spend a lot of time memorizing, right?
Yes.
You don't.
Right. I was looking, I kind of thumbed through the exams there a bit, and it looked like you guys did a good job. Okay, but
Except for what?
hang on, right? So. What's the point, though? Right? Now, remember, I told you guys that I'm not going to ask you guys to memorize something unless there is a purpose to it, right? That there's some reason why we need to know that, and we're gonna have to use it over and over and over again. Now, I told you guys that these polyatomic ions are gonna be everywhere, okay? We're gonna see them used as part of compounds, we're gonna see them used in biological systems, or they're gonna be part of reactions, they're gonna be part of our products, they're gonna be part of important acids and bases that we end up using. They're gonna be everywhere, so we should be able to recognize them, and we need to know the charge, and we need to know the composition, and all the names, and blah, 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 right? And one reason, or one area that we're gonna see them in is when we go through and do reactions. Now, these polyatomic ions, for the most part, they're just gonna exist as a whole unit, okay? And so what I mean is this. Let me scroll this down here for a second so I can point at stuff. So if you're taking a peek at this reaction, right, we've got nitrate, we've got nitrate, we've got sulfate, we've got sulfate, right? Those individual parts that are in the polyatomic ions are not going to be broken apart, okay? So when I'm looking to balance this, here I see one sulfate, right? Over here I see one sulfate. So we can just treat those as an individual part. We don't have to break apart the sulfur and the oxygen. Does that make sense? Right? So that makes things maybe a little bit easier if you guys start to recognize your polyatomic ions, right? So nitrate over here, right? 2 sodium, so we have to go back and we have to fix that, right? But when you see your polyatomic ions, treat them as a whole there. So see what you guys come up with real quick for this one. Not too bad, right? But then every question you ask, right? Makes it a little bit simpler if we just treat those polyatomics as a whole. Because then what do we have to just pay attention to? Well, we got one nitrate on both sides, we got 2 sodiums here, right? So what do we have to do over here? I'll just drop a 2 in front of it there, right? So 2 sodiums, 2 nitrates, we need 2 nitrates here. Right? We got 2 hydrogens, 2 nitrates, 1 sulfate, 1 sulfate. What are you guys also balancing along the way? The charges also. Right, now that's going to be important for some of these reactions that we're going to start to learn, okay? Remember, what does chemistry for us? Electrons, right? Remember, whether you have a negative or a positive charge, all we're really looking at is the absence or the excess of electrons, okay? Charges are extremely important. I've been torturing my organic chemistry class with this stuff this week also because they have an exam. You know what's going to be on their exam?
Electrons.
Charges, right? And they're going to use it the same way that you guys are here, okay? Yeah, what's up?
Okay, I tried to balance your equation, and I couldn't. You don't have parentheses next to the Na and the NO3.
I do not, that is very true.
Is that because the 2 just goes to the Na?
No, it goes to everything that's in there. So if you want to think about it in a manner like this, that's fine. That's just not how it's written unless there are 2 in the molecule itself, right? So if I had, just as an example, if I had something like, here, right? If I calcium nitrate, that means I have 2 nitrates in that molecule. And then I have to put that in parentheses.
Yes.
But if I have 2 molecules or 2 moles of calcium nitrate, I have to put the 2 out front there.
Okay.
Does that make sense?
Yes.
So the 2 here applies to everything in total.
Yes.
Okay? Cool.
Thank you.
Mm-hmm. All right, so when do we need to start checking for balanced equations?
Right now.
Right? So whenever I'm asking you guys a question about how much of a product gets made, how many moles of something gets made, what's the limiting reagent, and I'll explain that, right? Or what's the excess reagent, or any of these types of questions, you're gonna have to check to make sure that everything's balanced. If it's not balanced, guess what's gonna happen? The sparkly red pen of X has to come out, right? I have one of those, I don't know if I told you guys, but I'm happy because I bought one of those 128 packs of pens with colors all across the rainbow. And some even have glitter in them, right? Can you, right? How mad would you guys be if if you got a bad grade and put glitter on your exam, you open it up, it falls everywhere. God, I should have gotten 100. Then you wouldn't put right, right? But the point being, right? The point being that you guys need to start checking to make sure that everything's balanced. Okay, good.
Yeah.
You got plenty of weeks of class left to continue to practice that. All right. So here's the point, right? The point is this: once we have a balanced equation like we do here, okay, this tells us the ratio of how these things are going to be mixed together, right? This is telling me that I need 2 moles of that C2H6, 7 moles of that oxygen. I make 4 moles of carbon dioxide and 6 moles of water. That is what happens with this, okay? And these mole ratios is what we're going to use in our dimensional analysis or just talking about transforming or changing our units, all right? So when I ask you guys what are the mole ratios, I'm just really asking you guys to take a look at this stuff here and tell me how the equation is related to each other, okay? Because that's what we're going to do. I'm going to ask you guys, if I have 15 moles of oxygen, how many moles of CO2 get produced? Right? So if I have 15 moles of oxygen, how many moles of CO2 get produced?
30.
Well, hang on, right? So what we're going to do is we're going to have to convert moles of oxygen into moles of CO2. Got it? All we're doing is changing units. Does that make sense? And to change those units, we're going to have to use a balanced chemical equation. That's all. Okay? So exactly what you guys did for chapter 1 there with changing units in the metric system, right? We're going to be doing the exact same thing here. Okay? So our mole ratios, let me zoom out for a second. All we're saying is that right? For every 4 moles of CO2, I need 2 moles of C2H6. Could I flip that ratio? Yes, I can, right? Do you guys get what I'm setting up here? All we're doing is setting up how we're going to convert moles of one thing into moles of another. That's it. Okay? This is the same. This is the same as me saying this. Whoops. Well, if I can write. Okay? So my mole ratios, my stoichiometric ratios, is coming from a balanced equation. And that's how we can answer the question of how much of something gets produced, or how much do I need to make something. Okay? Everybody with me on that very important topic?
Yes.
Yes? Okay. Let's do this one first. Yeah. Then we'll go back to the one that was a wall of text. All right. Typical question. first thing you do? Scroll up for a second, or scroll back. What's the first thing you're gonna do? Well, write an equation, right? So take what I told you guys and transform it into an equation. Nope, you find something in sulfur, what? Trioxide into oxygen, okay. Oh, sorry, I thought you had SO there, so that's your 5. Okay, never mind, all right, pardon me. What's the first step you need to do for this?
Oh, so 1 mole would be balanced. So 1 mole of SO3 would be balanced out with this.
That's the first thing you gotta do. First you gotta write the equation, then balance it, and then use the 10, or whatever I gave you guys, right?
So if it had 2 moles balanced, then it would actually be 20 there.
No, not necessarily, right? What's step 1? Step 1's always the most common step. Sheer panic, right? Then after that, write your equation. After you write your equation, what do?
Cry?
Balance it, right? No, that comes in the first step.
No, you said sheer panic. Sheer panic doesn't always equate to crying.
So what is this saying? Sulfur trioxide, right, decomposes into what? Sulfur and oxygen, right? Is it important to know how to name things?
Yeah.
What is this not named? A very common mistake. Oh, it's SO3. I know the name of that.
That's
It's
an ion.
sulfite, isn't it?
No, because that's an ion.
Is this, exactly, right? Is this an ion?
No.
No. Right, this is just our buddy sulfur trioxide, SO3, right? What would make it sulfite? SO3 2 minus, right? Good. Remember, ions have different naming than covalent compounds do. So SO3, right, goes to make sulfur, and I tell you it's S8, and oxygen gas, right?
O2.
Hang on, right? Right. What's wrong with this?
Oxygen is a special one.
What do you mean it's special?
It has the
It's one of our diatomics, right? So when I say oxygen gas, or nitrogen gas, or hydrogen gas, or fluorine, or chlorine, or bromine, or iodine, right? These are all our diatomics, right? Don't forget that, okay?
I have no fear of cold beer.
Cool.
It's a mnemonic device for the diatomic.
Oh, is that what it is? Oh, okay. I had no idea. Good. Now that we have our basic equation, now your job is to balance it. All right, have at it. If you got it done, see if you can come up with the answer now. Everything, right? It's just like, yeah, it's just like multiplication, right? Everything, you can consider everything if you're like in parentheses. So if you multiply this by 8, it means you have 8 of those and 24 of those, right? Yeah. Yeah, so it's not gonna make it.
Gotta keep the string.
Don't use that number.
It's because I have all the bodies.
Ignore that number. Don't use that number.
Oh,
So ignore that. Good. I'll see if you can come up with. Good. See if you can. Yeah, real quick. So. What's this one? 2? No, just S. Oh, no, that's one unit. Yeah, you can't do that. You have to treat the whole thing like that. It is one, like it's one discrete part. So if you multiply everything, if you multiply by 8, everything is multiplied by 8. Yeah.
Why, for the top right here?
Yep.
Why is it that you got the 2 volts, this whole thing, or this whole thing? Why-
Yeah, but if I'm just relating one part to another, that's all.
Okay, but why?
Right, the 2 and 6 is the, right, for every 2 of these, I make 6 of those, for every 2 of these, I make 4 of those. I just picked one part of it. For every 2 of these, you need 7 of those, right? Every part of that is related,
Okay, but why don't you do that then?
because that's what this tells me. 2 of those makes 4 of those.
But only with this.
But only with that, correct.
Then why is this ratio, what's the ratio tell you?
It tells me how many moles I need, or how the moles are related to each other.
And for this part,
Mm-hmm.
right?
Yep, that's good.
And then do I find this divide thing?
Divide.
You know what I mean?
No.
The other equation, when we do combustion.
Yeah.
Yeah, so.
This isn't combustion.
It's decomposition.
Correct.
Yeah, so it's different.
Sort of. Yeah. Cool. All right. So when we have our equation written, the next thing we do is we balance it. I got 8 and 12 like that, right? That gives me 8 sulfurs, 24 oxygens, right? 8 sulfurs and 24 oxygens. Good? Have we used that number 10 yet? No. When do you use it? Now, right? After we have our equation, after we balance it, then we can answer the question of how much gets made. Got it? Get your equation, balance it, and then start to answer the question of how much. Okay? So what is this telling me? This tells me that I have 10 moles of SO3, okay? And what unit do I need to convert 10 moles of SO3 into? It asks me what? Moles of sulfur and moles of oxygen. You guys got it? So all we're going to do is play the game of convert moles of SO3 into moles of O2. Moles of SO3 into moles of O2, right? Or S8, sorry, I already said O2. You guys got what I'm saying here? To do that, we need the balanced equation. So here's what we're going to do, right? 10 moles of SO3, right? I need to get into units, whoops, wrong size pen. I need to get into units of moles of, let's start out with O2, right? Good? Everybody catch what I'm doing here? We are given information in moles of SO3, I need to get into moles of O2. So if my answer is in moles of O2, I better have moles of O2 on the top, and I need to get rid of moles of SO3. Good? Here's where my stoichiometric ratio comes in. What do I fill in the blank here? The numbers from your balanced equation there, right? For every 8 moles of SO3, I make 12 moles of SO2. Oh, excuse me, of O2. Everybody with me on this? Why do I talk through what I write down for you guys?
So we understand.
No,
We write it down.
it's not for you guys to understand. Who is it to understand? It's for me to understand. Do you guys get what I'm saying? Yes, it's for you guys to understand, right? But it's how I understand, how I go through, and how I think about this stuff. I'm sharing that with you guys. So what's your guys' goal? to be able to understand it in some way also, right? Is that important? Is it important that you guys know chemistry according to Dr. H? Or is it important that you guys know chemistry according to yourself?
Why not both?
Where does learning really happen? When you guys internalize it, right? Talk yourself through this. What do the numbers represent? Okay? So there we go. So if I did my math right, hopefully. Again, every time. Man, oh man. Right? 15 moles of oxygen. Got it? 3 steps to get here. Right equation, balance equation, use my stoichiometry. Okay? So see if you guys can set up to get to sulfur there. Set up the equation to get to sulfur. Good. Just play the same trick again, right? Convert one unit into the other. This is telling me that I have, for every 8 moles of SO3, I produce 1 mole of S8 from my balanced chemical equation. Got it? And so if I mathed it up properly, 0.25. Right? So what's the answer? For every 10 moles of SO3, I make 1.25 moles of sulfur and 15 moles of oxygen. Got it? That's it. Yep.
I don't see where you got the 15 moles.
How I got this? I didn't get it, I calculated it, right? I gave you information that we started with 10 moles of SO3, right? From my balanced equation, I get my stoichiometric ratio, which tells me for every 8 of these, I make 12 O2s. I don't have 8, I had 10, right? Does that make sense? So it's just we're setting up a ratio, right? The ratio is 12 to 8 or 8 to 12, whichever way you want to think about it.
Okay.
Make sense? Yeah.
So if you had like multiple like reactants like with oxygen in it, would you like do it to both of those to like see how much oxygen is in both?
It depends on the question that I'm asking,
Okay.
right? But with the equation, they're discrete units. So I'd have to say, how much of this particular component did I make? Or I could ask you something, how much of all the components containing oxygen were produced? Something like that, right? I'd have to specify what I'm looking for in that case. Okay. So there's the basic setup for a little bit more of a challenging problem. And there's some important information in the question here. Of course there's important information. I mean, there's some very, very, very unique important information. And don't worry, this equation's already balanced. I'll give you guys that one, right? My professor used to give us fake balanced equations.
That's just,
So they pretended to put stoichiometric ratios in there, but they were wrong. I will never do that to you guys. So it says blah, 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 blah. Excess BRF3. That excess word there is going to be extremely important. Extremely important. I'm going to give you guys a step to success, right? We've been doing all those steps. There it is written out, okay? So out of this subject, there are two major types of questions that come out of it. The first is this type of question that we're asking here, which is just me saying how much of stuff gets produced. The next type of question we're going to introduce is something called a limiting reagent problem. Okay? Limiting reagent problems are doing everything we did here, but twice. It's kind of how it is. All right? How do you know when you have to do a limiting reagent versus this type of problem? You see that word excess. That is what it's going to tell you. If I use the word excess in there, I'm telling you there is, well, I have to be careful here. If I give you the word excess, I'm defining what is the limiting reagent. Okay? Now, if you don't know that term or you haven't read it yet or done, don't worry about it. I'll explain to you in just a second. But the important part is the word excess defines what the limiting reagent is. Okay? So just be careful and pay attention to that. It's one of these flags for you guys to kind of start to differentiate what types of problems that come out of this. Okay? So we wrote out all the reagents, that's good. This is balanced. So you guys are starting here on step 3, okay? So if we condense everything down, that's basically what this question becomes, right? Start out with 25 grams of the TiO2, and excess of BRF3.
Okay, I see.
And it's asking us to figure out how much O2 and BR2 get produced, right? That's what it means. What's the first thing we have to do? Yeah.
Does that get that ratio thing?
Mm-hmm.
Ratios, right? You know the thing is balanced?
We know it's balanced, yeah.
Yeah. So is it ratios? Or is that not what we're doing?
Well, we will definitely use those, yes.
Convert 25 grams to this.
Perfect, right? You notice that I gave you guys information in grams. Are grams going to be useful for us?
no.
Nope. What is going to be useful for us? Moles. So step 1, convert grams into moles. Then we're going to use our ratios to convert moles of one thing into moles of another. And then you'll notice, what did I ask? The mass of O2 and the mass of BR2. So moles need to be converted back into grams. Got it? The GM-MG conversion. You guys are going to see this grams to moles, moles to moles, moles back into grams over and over and over and over and over. Okay?
Is this one of those things where you're gonna need to use Avogadro's number?
No.
Or we're gonna have to use periodic weights?
I would imagine so. How do we convert grams into moles? What information do we need?
The weight.
Our formula weights, right? Okay, you guys got it? To convert grams into moles, we need our formula weights. Check. How do we convert moles into moles?
You just do. Right?
What important bit of information do we need to convert moles of one thing into moles of another?
Moles of TiO2 into moles of O2 and.
For example, yeah, what information do we need to do that?
The coefficients.
Our coefficients from our balanced chemical equation, right? So this is our stoichiometry here, right? And how do we convert moles back into grams? We need our
Mass.
formula weights again, right? You guys got it? What's up?
Formula weight for Br2 and O2 double their periodic weight.
Mm-hmm. That's it. Yeah, what's up? Huh? Don't worry about that. I'll just check. Yeah. That's what you are. I'm just meaning, look, my favorite thing to do is, there's not many fringe benefits being a professor, but like making some people's nervous is one of them. So I'm sitting here and staring with like a shock expression on my face. Okay, so start by converting your given information after 25 years. Into this.
For example, the other ones.
Yeah, you did, yeah. But the other, the other end is I'm gonna make sure that that wasn't an accident. That she got that right.
Yeah, no, here I know that this one,
That's your radius ball.
Good. Now make sure you,
If I wanted to.
yeah, but make sure you construct that mathematically. Good.
Yeah, I mean physically.
Yeah, formula weight is a molecular weight, right? Same thing.
Sticks and stones.
What do you think? Yeah, that all means the same thing, yeah. There's like 3 words that kind of get thrown around there, so, yeah, don't get tricked by that terminology, right, yeah, you're good.
What is, okay, so if you're trying to convert this into moles, that doesn't work. There's no bromine in that. Does it?
Of course it is. But that's not what you're saying. You're not saying this is in that, you're saying this comes from that.
Okay, so that's how you.
Yeah.
Okay. Cool.
Right, and that's kind of what I was telling you, try to talk yourself through it so that it does make
Okay.
sense, right? Because otherwise you're like, wait a minute, what?
Yeah.
Where the hell did that come from? So there you go. right. You guys are good at this. You guys taken this class before, is that why? Yes, don't make fun of me. All right, we're good. What's that called? What's the name of this?
Titanium dioxide. Well, you know titanium oxide.
Nope.
Titanium
Special
2
numbers
oxide.
and-
Nope.
No, 2 oxide.
Wait, okay, well, which one is it? 1, 2.
Deep breath. Think about. Go
Is it
through.
4?
Oh,
Yeah, okay.
Titanium
4.
4.
Right, okay,
right?
titanium 4, okay.
Yes.
I remember.
Remember, always good practice, right? Keep your naming. Okay, so there we go. Titanium something oxide.
Because there's 2 oxygen, that's right.
Okay, right. Now we need to convert grams into moles, right? So 1 titanium plus 2 oxygens, I got it to be equal to 79.88 or thereabouts, right? Grams of TiO2 for every 1 mole, TiO2. Good?
What the heck did I do?
Right. And that was, actually, I think it was a common.
Now my units are in moles of TiO2, so I can convert moles into moles.
Big stupid.
So for every 3 moles of TiO2, let's see, I think I start out with oxygen, right? So I have 3 moles of O2, where I produce 3 moles of O2. And for every 1 mole of O2, I have 32 grams of O2. Okay. So you guys have to string everything together like this. No. Can you guys break apart each individual component? Yes. Which way should you do it? Whichever way gets you to the right answer, right? Whichever way makes the most sense to you. Got it?
Yes.
I don't care. Just show me what you're doing, right? That's all I ask. And if I did my math properly, I got about 10 grams of oxygen here. Is that what you guys got?
I have not gotten that.
Okay, that's fine. Okay. What would the next set of equations look like then, right? So see if you guys can come up with BR2 then, okay? Yep, sounds good.
Why did you put it in class? Don't look at the science like that. This is not the science you put.
Well, it's what's coming out of this here, right? Oh, you had this reversed, right? No, I'm sorry, yeah, no, you got it set up right there, haven't you? Ignore what I just said.
Aliens always archaeology.
Essentially, right, but the important part is not necessarily what the answer is, but how you set it up, because it's not always gonna be that case, right? In fact, you know, for the next one, it's gonna be a different ratio between the two, right? So that's what I'm saying, make sure you understand what each part of it does. About 159. Cool. Grams into moles, moles into moles, moles back into grams, right? Yes.
So the top one that you just did.
Yep.
How did you get the 32 grams? Like mine had
This?
13 grams. Yeah.
This is the formula weight for oxygen here. right? Each oxygen is 16, there's 2 of them, 32, right?
Oh, okay.
And if I did my math properly on the bottom, I got about 33 grams is what I have written.
Yes.
Good? Could you guys do it for the one I didn't ask, the TIF4 there? You sure could, right? Does this all make sense? So that's the real question, right?
Actually, yes. I'm surprised.
It's a very complex sounding problem, but how do we solve it? Grams into moles, moles into moles, moles back into grams. Only 3 steps. Okay?
What's the significance of the excess beyond F3?
Huh?
What's the significance of the excess per?
It'll become evident in just a minute, right? At the moment, all we're saying is we don't have to worry about it, right? Because there's as much of it there as we need.
So it's
So we're assuming only the TiO2 is what is
what's gonna
interesting to us, if you want to think about it that way. Yeah.
So, on the top you say
Yes.
3 moles of O2, and then
Uh-huh.
the bottom equation says 2 moles of BR2.
That's
Are
correct.
you getting that information from this second half of the equation?
Mm-hmm. Yep. That's from our balanced chemical reaction, right? So that's what our stoichiometric coefficients next to us tell us there.
So you're always gonna pull from that side?
Well, you pull from whatever I ask you to, right?
Okay.
Because all you have to do is say, where is this in my equation? And then you look for the integer that's out front.
Okay. How did you know to do it?
How did I know to do that?
That it says do 3 moles and 2 moles.
It's from the exact, it's just a ratio, is what it is, right? I'm just looking at these numbers here. 3 TiO2s make 3 O2s. 3 TiO2s make 2 BR2s. That's all it is. Extra space for you guys. All right. See what you guys come up with. You guys notice that very important key word in this question? The excess, right? So that gives us a kind of clue. And I promise that clue will be more evident as soon as we go through the next part of the chapter here. But
So on like a test, right? If we're writing out our equation
Mhm.
or something, must we put the like the aqueous, the solid, in parentheses?
are you saying, do you need to write this properly?
Well, okay.
I'm gonna go with yes.
How do we know what's gonna be solid and what's gonna be aqueous?
I'll tell you, or we'll have some information about it.
What's the significance of that?
What's the significance? The significance is going to become important when we start to talk about enthalpies of formation and enthalpies of reaction. Because water that's produced as a gas is different than water that's produced as a liquid, for instance, right? And so right now, the significance isn't as evident as it will be, I guess.
So doctor,
Mm-hmm.
do we need to start by essentially adding up the entire weight of the left side?
No, I would say that the way we start this out is by writing an equation, making sure it's balanced, and then figuring out our stoichiometric ratios of things. Did you see, right? I just need to figure out how much magnesium I have. That's what it is. Magnesium has to come first. That's all it really comes down to.
Well, doesn't it just say how much magnesium that there was?
No. So I had a sample that had some magnesium in it, right? How much of that was magnesium?
So. Can this reaction be reversed as well, or is it like only one way?
All reactions can technically be reversed.
Okay. Well, okay.
Or at least expressed in terms.
I have a question.
Yep.
So we have CO2 and we have 2CO. Is CO2 equal to 2CO? Or are they different? Why are they not different?
What do you mean?
I thought we had two of them. Can we do that?
How many chlorines do you have here? Two. How many do you have here?
But this was it.
Yes, they are. They did a reaction, right?
And so that all this means is just like a different appears not necessarily.
Correct.
Okay.
I didn't say that they didn't change their properties. I just said they have to be balanced. Yes, yes, they're going to change. They're going to gain or they're going to lose electrons, all this kind of stuff, right?
Okay, thank you.
So what am I telling you guys here? Watch. I produced that much NgCl2, right? So I'm telling you how much of a product I made. And I'm saying how much magnesium did that come from, okay? I didn't say I started out with 1.72 grams of magnesium. I said I had a sample that was 1.72 grams. Got it? It had magnesium and something else in there. Who knows? Okay? So watch. Here's what we're going to do. It's going to be really tricky. You ready? I'm going to take grams of magnesium chloride and I'm going to convert it into moles of magnesium chloride. I know, I was shocked when I learned this also. Right? Okay? Now that I converted grams into moles, I'm probably going to convert moles into moles. Okay? Moles of what into moles of what? Moles of magnesium chloride into moles of magnesium, right? Because that's what I need to figure out my information for. So what's the ratio of magnesium chloride to magnesium?
1 to 1.
There you go. Would it be important to write that information out? Yes, it would. Why is it important to write this information out?
Because life is pain.
That we don't mess something up.
Right? Why is it important to write this out? Can you guys multiply everything by 1? Yes. That's not the point of what we're doing. What's the point of writing this out? The point is to understand how the units change. I don't care about the math, I care about the units. You guys with me on this? This tells us how we're setting up and converting one component into the other. Grams into moles, moles into moles, moles back into grams. Oops, 0.06785. does that 1.649 number tell me?
How many grams
How many grams of magnesium
were in the
produced what?
the magnesium?
6.46 grams of magnesium chloride. You guys with me on this? Does that make sense? This is the most important. This is the, I say every part's important, but this one's the most important because it's the one I'm talking about now. Right? If you guys are just looking at this and saying, yep, it's a number, you're missing the important part. Talk to yourself about what that number means. If you don't, it's just going to forever stay as a number, and every time you work this problem, you guys are going to be confused and you don't know what you're doing, and oh my gosh, and everything gets panicky, right? Talk to yourself about what you're doing for each step. This right here tells me I took 1.649 grams of magnesium and it produced a 6.46 grams of magnesium chloride. That's what that tells me. Got it? But I didn't start with 1.649 grams of just magnesium. I started with 1.72 grams of something total. So my original sample was 95.9% magnesium. Right? Who cares what the other percentage was? Good. What are the conversions? Grams into moles, moles into moles, moles back into grams. We're going to learn something next class period. And guess what the math we're going to do?
More mass.
Grams into moles, moles into moles, and moles into grams. But twice. Ooh. And sometimes even 3 times. No! Okay? All right, so if you guys have questions, come up and see me real quick, okay? What's up?
Yeah.